Hello everyone, grade 9ers for chemistry. Today we'll start our first lesson in chemistry, which is going to be about electricity and chemistry and how they are both connected to each other. Here we're going to talk about mainly how we use the process electrolysis to actually how we're going to distinguish or more likely to separate the positive and the negative ions inside of whatever sort of substance we have. For an example, the substance that I want to separate its ions, I would actually name it electrolyte, as it's here said. And as an electrolyte, we've got an aqueous solution of ionic substance or molten ionic salt, and it has to conduct electricity, because here it's like we're separating it using current, so in order to separate it to positive and negative ions. And therefore we will explain furthermore in the upcoming video. Electrodes, which here we've got something called the anode and something called cathode. The anode here is supposed to be a positive electrode, meanwhile the cathode is negative. But for an example here, the rods which help current enter the electrolyte, we've got two types. We've got inert electrodes, which don't take part in the reaction, and we've got reactive, which take part in the reaction, so it depends here. Okay, there's a general idea. As for here, this is the experiment. We've got here the substance that we want to electrolyte. We've got the cell over here and the current passing through. Here, the cathode, the negative part, and this is the electrolyte. The ions here that would be attracted to the cathode would be positive, because the cathode here is negative, and the vice versa over here. For the anode it's positive, and the ions which go through here it's actually negative. Okay, as you can see over here, the negative charge ion becomes an atom after losing electrons, and here on the positive charge ions on the cathode, they gain electrons. As for the general principle for the cathode and anode, is that the molten electrolyte, it means I've got a substance and then it has been melted or molten. So those who go on the cathode are metals, and those who go to the anode are non-metals. Meanwhile, in an aqueous electrolyte, so the substance is actually a liquid, at the cathode we've got two things. Those who go to the cathode are either high in reactivity or low. Those who are high in reactivity, then hydrogen is formed, and those who are low in reactivity, then the hydrogen, a metal, is formed. As for the anode, there's a halide present and halide not present. For an example, if there is a halide present, it could be concentrated and a halogen is formed, or dilute, that means it's not highly concentrated, and an oxygen is formed. While we don't have a halide present, so practically we've got oxygen formed. Now we come to the process of electroplating. Electroplating here is actually covering or coating one metallic object with another metal using electrolysis. For an example here, look, we've got the battery, we've got the electrons over here, the cathode and the anode, and for here an acid solution with free copper ions. Why do we use electroplating? We use it actually to either improve the property or improve this sort of metal. For an example, I've got silver as a jewelry, but I wanted to coat it with the gold sort of thing. A layer, so it gives me a better appearance. Or I'm going to cover this metal to prevent it from rusting. As we know, some metals that when they react with oxygen they rust by time, like iron. So Sometimes like I would cover it or electroplate it with, coat it with another material or another metal in order to prevent the rusting situation. For electroplating here, we need a node made of metal that you want to electroplate an object with, and ions of the same metal as a node in solution, and the object to be plated at the cathode. The chemical energetics. We've got here energetics of a reaction. Any substance or two substances that they bind together, they would form or go through a process of a chemical reaction. But here we've got an exothermic reaction and an endothermic reaction. The exothermic reaction is the one that actually releases heat energy into the surrounding. Meanwhile, the endothermic reaction is the one which absorbs a heat energy from the surroundings. The bond breaking is endothermic. Meanwhile, the bond making is exothermic. Here's a simple difference between each one of them. The exothermic reaction, energy is giving out to the surroundings. Meanwhile, here is taking in from the surroundings. The surroundings here become hot in the exothermic. Meanwhile, in the endothermic, they become cold. As for the exothermic, it's a bond making, but meanwhile for the endothermic, it's actually a bond breaking. Okay, of energy. For an example here, we've got the fuel in general. A fuel actually is a substance which can be conventionally used as a source of energy. Burning fuels like oil to form oxides is an exothermic reaction. The heat from burning fuels is used in power plants to create steam and water and to turn turbines. In order for any material to combust, that means actually be burnt, three things must be present. You have to have like the triangle of combustion, we call it, is that you have to have the fuel and the heat and oxygen. Because when you want to burn something, how would you burn it if you don't have enough oxygen? How would you actually burn it if you don't have heat? And how would you burn it if you don't have the fuel to make it burn? Or actually the object that you want to burn. A good fuel would actually be cheap, be available in large quantities and liquid at room temperature and produce large amount of energy when combusted. That means when actually burnt, and doesn't produce polluting gases. As for the hydrogen here, it burns explosively with oxygen, so they use it most likely in rockets. In a fuel cell, it combines with oxygen without burning, and produced by reacting methane gas with steam. The advantage and disadvantage of hydrogen. The good things, which are the advantages, it produces like a lot of energy, abundant on Earth, practically sea, less pollutant and renewable fuel. That means you can always find it, never runs out. Meanwhile, the disadvantage, the bad thing about it, is that it's difficult to transport, as it's a gas at room temperature, and forms an explosive mixture with air, so it's practically very dangerous. Okay, the radioactive isotopes. For an example here, we've got the uranium 235. It can be used in nuclear power stations to produce electricity, and the radioactive isotope is bombarded by nutrients, resulting in a lot of heat being produced. The small amount of radioactive fuel produces large amount of heat. One of its advantages is that lots of energy is from a small amount and number of carbon dioxide. The disadvantage is like the radioactive waste produced and non-renewable. That means I can't actually have it. Can't have it like all the time. Like once it's gone, and it takes time to actually rehab it again. The chemical reaction. The chemical reaction here. We've got the collision theory, and then we will go through the rate of reaction. The collision theory here, it's like all about the collision needed for a chemical reaction to take place, and the successful collisions have enough activation energy at movement of impact to break pre-existing bonds and form new bonds. It's more likely as the particles, when they actually slide against each other, the more kinetic energy you have, the more collision you will have. The rate of reaction. The rate of a chemical reaction is actually the concentration of the reactant used or a product made in a given time. We've got several factors that actually controls the rate of reaction. The first one is concentration, temperature, and particle size, and the light as well. As for the concentration, increasing concentration of reactants actually increases the rate of reaction. Why? Because there are more particles per unit volume, so the collision will be much more. As for the temperature, increasing the temperature also increases the rate of reaction because the average of kinetic energy of the particles increase, which means they are moving more faster. As for the particle size, decreasing the particle size, meanwhile increasing the surface area, what does it do? It increases the rate of reaction. The catalyst. The catalyst here is a substance that we usually add it to a chemical reaction to speed it up. For an example here, like enzymes in general. Enzymes are proteins. Enzymes are catalysts. We add them to enhance or more likely to speed up a chemical reaction. So enzymes are protein molecules. They are biological catalysts which speed up the chemical reaction but remain chemically unchanged at the end. The enzymes function best at optimum temperature and pH level, otherwise they would go through denaturation. That means the complete change of the enzyme and it will stop functionizing. Also, we have here the light causing a chemical reaction. Even the light here controls the rate of reaction. For a photochemical reaction is one where the light causes a reaction to occur. The higher the light intensity, the higher the rate of reaction. And also for photosynthesis, the light provides here an energy as well. And as for the several salts in photographic films, the silver bromide here breaks down where the light strikes the film. So here the silver is reduced, meanwhile the silver ions are reduced to silver. The reversible reactions. Any reaction which we can take it back, it's called a reversible reaction. By means, it's like if I take a hydrous solution and I take the water out of it, it will be unhydrated. But if I add the water back again, it will be hydrated. So practically here, it's like I can make the process going on and I can take it back. But there are some sort of reactions that we can't take it back, so we call it irreversible. Like when we burn something, combustion or burning items or subjects, it's actually an irreversible reaction and we can't take it back. A reversible reaction is a reaction in which reactants form products and products can then react or decompose to form reactants. For an example here, we've got copper sulfate with water, which is a hydrated form. So we can actually, if I more likely as heated, all the water will be evaporated and I will have just an anhydrous solution or anhydrous matter. But when I want it to be hydrated again, I would add water again and it will be as it was before. So this is what we call a reversible reaction. There are two types of equilibrium. We've got a static and dynamic. At dynamic equilibrium, the rate of forward reaction equals the rate of reverse, and concentration of all reactants and products remain constant. That means they don't change. Here we go to the last thing, which is the redox reaction. Redox reaction is a reaction that has two things. It has a reduction and oxidation in between. Oxidation, it's more likely as adding in oxygen, and reduction, it's completely when we say we have like we actually gain electrons out of it. The oxidation means here loss of electrons, and reduction means gain of electrons. The oxidation means gain of oxygen because we're adding it, but loss of hydrogen. Meanwhile, the reduction is loss of oxygen and gaining hydrogen. Thank you for listening, and I'll be waiting for your questions.